Gold is the softest and most malleable metal. It can be pressed extremely thin, crafted into various shapes, even drawn out to form a fine wire, and all without breaking. Gold isn't affected by water or oxygen as many metals are, so it doesn't rust or tarnish either. Most gold comes from lode deposits, also called vein deposits, concentrations of gold and other metals in the cracks of rocks. Lode deposits require hard rock mining, the process of removing gold-bearing rock, called ore, by drilling and blasting. Miners descend more than half a kilometer underground. There, they drill holes for explosives using what's called a long-hole air drill. They drill in a specific pattern set out in a plan prepared by the mine's engineers. The engineers know exactly where those veins of gold are, thanks to the mining company's geologists who've studied ore samples. The company collects these samples by drilling deep into the rock at 15-meter intervals. These diamond drill cores, as they're called, are up to 100 meters long and measure 3.5 centimeters in diameter. Gold in its natural state isn't pure. It's usually intertwined with silver and other metals, so the mined ore has to be processed afterward to isolate and extract the gold. A metric ton of ore yields only about 6.5 grams of gold. After blasting the rock apart with explosives, miners use what's called a muck machine to transfer the ore to cars headed to the main shaft and then above ground to the mill. There, a crusher reduces the large chunks into smaller rocks about the size of road gravel. A mill then pulverizes them to the texture of beach sand. The factory adds a water and cyanide solution, then another mill grinds it further into a mud-like pulp. The pulp flows into large settling tanks. The wet solids, being heavier, sink to the bottom. The water at the top drains to another area. They transfer the wet solids to an agitation tank and blow in air. The oxygen sets off a chemical reaction between the cyanide and the gold trapped in the ore, triggering the gold to dissolve and leach into the surrounding water. Drum filters then separate the water from the solids. This water now joins the water that was separated earlier. They pour in zinc powder to solidify the dissolved gold and form pieces containing both zinc and gold. To smelt it into bars, they first have to mix several chemicals: manganese dioxide, fluorite, silica flour, borax, and sodium nitrate. This chemical mix, called flux, will separate the gold from the impurities. They pour it into the smelter, whose temperature is a fiery 1600 degrees Celsius. They rotate the smelter so that the contents heat evenly. Over 2.5 hours, the heavier gold eventually sinks to the bottom, while the impurities, called slag, float to the surface. They pour out the slag, taking a sample to make sure it contains no gold. If it does, it goes back in until it's gold-free. By now, the gold has cooled slightly, so they reheat to 1600 degrees Celsius, then cast into bar-shaped molds. The gold takes about 4 minutes to solidify, then another hour to cool completely in a basin of cold water. They extract the gold bars from the molds and clean off any slag residue. Gold bars are also called ingots. At this stage, the gold is 80% pure. The Royal Canadian Mint will refine it to 99.9%, the international gold standard.